All right, guys, we're back.
Yeah.
Video's got my studio on. See you again today.
Yay.
So Brianna, say yay. Okay. We're in what's it? Wait, 9.3. 9.3, solving rational equations, which ultimately of the addition and the multiplication, this is where it's supposed to be leading to. Okay, this is where all that's supposed to be leading to. Is this point in time. So if you forgot everything for 1 and 2 and you remembered 3, that'd be better than the reverse. Okay, that'd be better than reverse. So let's get started here. First thing we're going to need to do is see what kind of weirdness is happening there. Isn't that great? Let's hit this button. Let's see if we can't get that to stop. Here we go. All right. So what is the LCD? Because we're clearing the fraction is what we're going to do. What do I mean by clear the fraction? See if I can help her get you to remember a little bit. Remember we had things like 2 over 3x minus 4 equals 6. And so what could we do here to clear the fraction so we don't have to mess with that 2/3? And so, well, what's the greatest common factor? Well, this one's pretty easy because there's only one denominator. Well, least common denominators, but I should have said one there. So, manually edit that if you don't mind. All right, so here we go, 3. So I'm going to do 3 times everything here. So that's the 3's cancel, so that leaves you with 2x down here. The 3 doesn't have anything to cancel with down here underneath, right? They're over 1. So that's going to give me negative 12 and then 18. This is what we're trying to accomplish with these rationals, is multiply through by the least common denominator so we can get rid of all of the denominators. That's the point of what we're trying to get to. Okay? So I don't know if everybody understands the reason why we've done it, what we're trying to accomplish. So back over here, LCD. Well, we got 12x, 6, and 4. Let's look at the factors of 12. 12 has got what? 2 times 2 times 3 times x. So that's 4 times 3 and then times x. Okay, what is 6? That's 2 times 3. And then 4 is 2 times 2. So what do they already have in common? What do they already have in common? They already have this 2 in common. So that's going to have to be part of my least common denominator. Okay? So I got a 2. Do they have anything else in common? A couple of 3's? Okay? So that needs to be part of my least common denominator. Anything else in common? Okay, you got a couple of 2's. Now, do they have all of them in common? No. But if I'm going to have something in common with all of them, they're going to, if I have 2 of them, I need at least 1 of them over here. Okay, so I got a 2 here. Now this 12x has an x. These don't. So can I just leave the x off since they don't have one? Or do they need to get one? They need to get one. So I'm still going to have an x involved in this process as well. So the whole thing turns into what? Basically back to 12x. So we're going to multiply every single thing here times 12x, the least common denominator. I'm going to go ahead and write this out individually. So it's going to be 12x. I'll put it over 1 just to help emphasize what's going on here. That's ugly. Let's try that again. 12 times 9 over 4x, okay, and minus 12x over 1 times 5 over 6. Now, what about this whole subtraction thing? Well, if I wanted to leave the negative with the 5, that's okay to do. I just would have to put a positive out here because I don't want negative negative. That would change the situation. So either put a plus sign here in the -5, or just leave the negative sign and it'll land where it's supposed to later. Okay, so let's put our equal to here. And I'm going to go ahead and write this 12x again times, watch that sign at -13. Because of that being written that way, you could miss it very easily. 12x here. Now I don't have to write it all the way like this, but I do encourage students to do this as they're because it's easier to keep track of things. And I was talking to a student earlier today, and it's not that I can't do it, it's that it's so long it's hard to get through the whole thing without screwing something up. And yes, so there are certain practices that we can do, certain strategies we can use to help reduce some of those errors. And this is one of them, by taking a minute, and it usually means writing more, not less. So now let's do some reducing. So I see that these x's can cancel each other or reduce to 1. 12 and 4, well 4 goes to 1 and 12 goes to 3. So if I collect my like stuff together here, I get 3 times 9 over 1, also known as 27. Okay, go to our next piece here. So I see 6 and 12, so the 12 turns into a 2, the 6 goes to a 1. Anything else to reduce? No, don't see anything else. So we got -2x times 5, so that would be -10x. Again, -2x times 5, which is -10x. Watch out, don't lose that little piece sitting right there. Equal. See, now we got 12x and 12x reduce all completely. So and that just leaves us with -13. So that's what the whole point of what we're doing is, to get this where we don't have any denominators. Now it's just solving the equation like you always would. If it's linear, trying to get x by itself. If it's a quadratic or cubic, you're trying to get it equal to 0 and then go from there. Let's see here, it's trying to get our x by itself, so we're going to subtract 27 from both sides of the equal sign. And we're only adding, subtracting like terms, always, always, always. So these cancel out, so this gives us -10x equals -40. Yeah. And then now we're going to divide, because that's the opposite of multiplying right here, right? So divide by -10 to get that x by itself. And we get x equals 4. Now is this all good? Well, it's kind of good, except for one small problem. We haven't checked it. Because since we moved into this whole exclusion world, we have to check it. But did we square anything? No, we didn't square anything, so we could actually skip that step. Because it's when you square all the way through is when you cause problems. So I think we're pretty good there. But how could I check this? Again, I could put a 4 in here, simplify it, and it should give me the same thing as the other side as well. So there's number 3. Yeah. Studio audience, am I missing something on number 3? Exclusions. What could x not equal? 0. That's the only thing that would make the denominator 0. We'll tack that onto the edge of that. Okay, this is going to go away. We're going to start fresh with the next problem. You should recognize the next problem from your quiz. I don't know if it's the exact same numbers or not, but it's really, really close if it isn't. All right. I think one version had a 3 here and a 2 there, and the other one had the 2 and the 3 that way.
Yes, sir.
So all works out. So here, let's put a 1. Put this over 1. So is there any common factors with our denominators? There aren't any common factors at all. So our LCD ends up being just 7 times x plus 1. So that's what we're going to multiply everything by. We'll multiply everything here times 7 times x plus 1. This is not 7 times x plus 1 over, is it? Not over at all. If you did, that would work out, but you just make sure you do what? All the way through, and what you're going to end up with, back what you started, it wouldn't really be that helpful to you, okay? Because some things would cancel, and then some things would just show right back up, and you would be back where you started, basically. So not very helpful, okay? The only thing that would change is that these two things would change positions, not much else. So this is going to be much more helpful, but let me write it out individually so we can see exactly what's happening. And I'm going to go ahead and leave it in the factored form because it makes it easier to reduce. I'll put that over 1 just to emphasize that. We got 3 x plus 1, 2 over 7. I'm not really worried about what I'm reducing and things like that at this point. I'm just making sure I write what I need to do and then come back through. Now I could multiply this whole thing out and then reduce later, but that would be a lot of extra work for no good reason. So this is multiplication here, right? So I can say x plus 1 and x plus 1 since there's 1 on top and 1 on bottom. So they reduce to 1, and what does that end up giving me? Just 21. Okay, go ahead and bring down that. It's going to be a plus, but I'm going to leave it be for the moment. Okay, come over to this next piece. So 7 cancels with this 7, it reduces to 1. Anything else? No, nothing else reduces. So I'm going to get myself plus 2 times x plus 1. Okay, we'll need to multiply that out, but that's enough for the moment. Okay, anything reducing over here? No? Now here's the thing. People have getting a little bit confused. So what I want to do is I want to come over here and ask you, if you had 7, something that looks like a 7 as opposed to a 3, okay, 7 times 1 times 2. You're not going to do 7 times 1 and then 7 times 2 as well. What you're going to do is what? Do these two, bring this down, and then you're going to do these two. Okay? This is the same thing here. You're going to take 2 pieces at a time and then go to the next one. So I'm going to take 7 times 2, because that's easier to work with. And give me and say 14 times x plus 1. Okay? And now we can distribute those out and go from there. So let's keep on going. We got 21 plus 2x plus 2 equals 14x plus 14. Okay, there's no squares running around, so it's not a quadratic or a cubic or anything. So it's just a linear, so we're going to get x's on one side and constants on the other. We got the 14's over here, so let's bring all the x's over here. Seems like the easiest way to do that. So let's subtract 2x here. Subtract 2x on both sides because we're doing like terms, because we always do like terms. I can bring my 21 and 2 down, but you know, I'm real bright and I can come up with 23 there. So that's 14 minus 2, 14x, that's 12x. And we'll leave that as 14, positive 14, watch your signs there. Get a little closer. Got to get rid of 12 and 14. Let's do the 14 first. Both sides here. Is that 9? positive 9. And 12x. And here's a step that people get in a hurry and just do in their head, and they get things backwards. The next step is to divide both sides by 12, okay? But sometimes they do this in their head and they get 12 over 9 instead. And so they get exactly the opposite of what they were trying to get accomplished there. And so they were so close to the right answer, and then they take a shortcut that messes them up. So just tell you, watch out for that. So that 9 over 12 reduces to 3 over 4 equals x. And again, since we didn't square anything all the way through there, this should be just fine. And so x equals 3/4. Be better to plug it back in. I think you can do that without my help. Any questions? Okay, I didn't screw anything up. Awesome. Okay, well, that's solving rational equations.